Alright,
Sorry, it's been
Is
so
it on?
focused on this problem.
Yeah, it's on.
alright.
Been doing
Here we are putting
Okay.
these values into the range equation, and when you cranked it out, anyone need more time on the crank part? Alright, I got with sig figs 2900. Anyone else?
That's what I got.
2900. Alright, 2900. If you got that, and that's in meters. Here, I wrote that. 05. Let's use the range equation again and just change the scenario. Instead of 20, it's going to be at 35. And I know the range. The range is 3,120 feet. And so guess what I'm going to ask for? The initial velocity. So this is our next one. Find the initial velocity in this scenario where we're aiming at 35 degrees and it went 3,120 feet. Are you running out of paper?
Yeah.
You want another one?
Yeah, that'd be really helpful.
Anyone else need another one?
Yes,
Just put on that on the top that we're in mod, what, 4?
4, yeah. Thank you.
You're welcome.
So you got 41,000. Zach, you got 41,352,
Yeah, then just rounded to 41,000.
and then you took the inverse tangent of that number.
No, that's just well, yeah, you gotta take. Well, you have to take the inverse tan of y divided by x from the original from. Well, not from the original. From okay, so you know how before you Pythagoras, you have to take those two values and divide inverse tan of y divided by x, and that's how you get your.
So what was your y, Zach?
My y was
oh, this is easier head.
3,751, and my x was negative 41,319. And so when you do that, you get negative 1. I think it actually came out to perfectly negative 175. No, it was like one. It was like 0.5 something, and then you have to add your 180, and so then that's how you get it.
Got it.
There you
Yay.
go.
That's,
Good job, Brian.
somewhere along the way, I did something. Well, I couldn't find out where.
Okay, well. Now we're looking at this range question. We have the range is known and we're putting in the angle and we're looking for velocity initial. So it becomes a mathematical equation to solve. So go ahead and put in the numbers and solve it for V sub O. The last step will be taking a square root. So don't forget to do that. You got the answer yet?
Yeah.
Okay,
Sorry.
that's fine.
Yeah, blame it on me, Zach.
No, Brian, it's not your fault.
What's wrong with you?
You understood the problem, which was what was. That's the important
Yeah, I'm
thing.
not sure what it's true.
Like Mrs. Powell said, if you
Yeah,
don't
I've got
understand something,
three
just
for
say
you.
something. They work one together.
Because
Excuse me.
you didn't know, do you?
Yes.
That range is 3 seconds and 3 seconds.
Ready or not, the velocity initial, rounded, is 330 feet per second.
Got it.
Anyone confirm?
Yep.
Alright. I put in some of the math, I multiplied by 32 and got this, and divided by 0.94, which is the sine of that, and got this, and took the square root. So I showed you some of the math there. If you got 330, you may cross out G3. Alright, 35. Take 5 more minutes of problems and then we'll switch to, do you prefer, we'll probably have time to do one more. Do you prefer this one or the kind where they kicks the football?
That one.
This one? Okay, they're both kind of the same, really, same principle. Alright, we have the diver, and the diver is diving out with 20.0 feet per second is the initial velocity of the diver. And the cliff is 35 feet high, very high. And we might change that. It won't be a person going off or throwing a water balloon off or something. 35 seems a little dangerous. And I want to know how far from the base of the cliff the person lands. So.
Alright, is V sub equal to 0 or 220 feet per second? Which one is it?
The angle
Uh-huh.
was given as 0, and the initial velocity is 20.
Okay, I was confused because, alright, okay.
20.0.
I was looking at the Y one, it was like which one to go to.
Oh yeah, that should be up there. You should come knowing that.
Yeah.
I forgot we already established that.
It's pal.
Yeah?
For acceleration and X,
Yeah.
wouldn't that like decrease? Wouldn't he like decelerate?
No, because
Because he's
when
evening out.
we drew the triangle, how the x components are all the same,
Yeah, but
no matter
this
where
is
it
different.
is.
It's not exactly the problem because eventually he's not going to go any farther in the X direction, is he?
What do you mean when he hits?
Yeah, eventually, like he's going to straighten out eventually.
I mean, even here, there's an x component too. So say it has a tiny little slant to it.
Yeah, but that
It'll
means.
be so long that it'll still have an x component that's equal.
Oh, I see. I see.
It's amazing, I think, that it does that, but it truly does. Alright, if you started down the x equations, you would find a dead end. So here's my dead end, because I didn't know the distance in x and I don't know time. So I'm going to go to the other side of the world, the y component, and find time. Remember in lab you had to do that for the rubber band and the golf ball and the water balloon. So we did the same thing 3 times in lab. This is negative R25. I'll stop right there. You can borrow that information.
Because it's 32.
Did you get the time part?
Wait.
Do you get the time part?
Hold on.
No?
Hold on. Okay, now I got it.
I made a stupid name.
I wasn't sure because, like, I have the time, but I wasn't sure if I should round it or not.
I do.
You did? Because it gives you, like, a different answer.
Yeah, you get a different answer, it's definitely, but it shouldn't be too far. Did you use this?
Yeah, I did too.
That's what I used.
And it's 30.
Yeah, so now you put
You have to,
you put 1.5 up here. 20 times 1.5 gives you, round it, and well,
but should you
actually,
do 3.0 times 10?
And
So
get
that you know
30
there's 2 significant. Or is there not 2 significant?
for what? I put, when I gave the problem,
Because it says 20.0. times 1.5.
I said 20.0, so that's 3, but whenever we use the 32,
But then you have 1.5 and
Yeah,
32, so
right.
it'd be 2, so it would be 3.0 times 10, right?
yeah.
Just do 30.
Yeah, sometimes I cheat and do 30 point, that's weird, but it does tell the reader that both numbers are significant. So we ended up with 30 feet, did you get there?
Yep.
Alright, they're landing 30 feet from the base of the cliff, so this is 30 feet. Alright, if you got 30 feet, cross out O2. Alright, let's switch over to theory now. Pull out your review sheet and let's see how you did on that. We had gone through number 8, so we're on number 9. So number 9 shows a parabolic projectile in it is a parabolic path. And notice it picked a point A and it picked a point B, and they're right across from one another on the parabola, number 9. So are you with us?
Yep.
Brian, do you have your number 9 from yesterday?
Yes.
Okay, good.
And we're approaching 11 minutes. For one.
Okay. You were ready?
I can read.
All right, here we go.
Give me a second.